Welcome to the video presentation of the patented Efficient V piston engine technology, designed to eliminate the limitations inherent in the operation of crank connecting rod piston slider geometry. That is the core basis of operation for virtually all piston engines, pumps, and compressors. We have two examples to help explain operation. This first example is a crankshaft, connecting rod, and piston from a small single-cylinder engine of conventional arrangement. The geometry of this arrangement inherently produces high friction, high piston acceleration-deceleration, stress, and wear, and limits piston dwell, reducing the time for complete efficient combustion and energy conversion to work. As the piston reciprocates in the cylinder, the angular geometry of the connecting rod thrusts the piston into the cylinder wall, producing the majority of friction present in a conventional piston engine, and is the principal limiting factor for efficient, emissions-compliant service life in most piston engines. Note the scoring and wear present on the piston skirt. The Efficient V model shown here is but one of the many ways this technology may be implemented. Efficient V may be configured with virtually any cylinder bank angle and as a highly efficient V4, or as a radial of 3 or more cylinders, and it is completely scalable. This is a 3D printed 120-degree cylinder bank angle V-twin that is a half-scale 939 cc example. The core components and arrangement are illustrated and discussed here. 120-degree bank angle V-twin cylinder block. The cylinders have a narrowed region that transects the crankcase and journals a corresponding narrowed elongate element of the pistons. The pistons with elongate cylinder journal elements receive and dynamically journal the crank pins of the compact planetary crankshaft, which have pinion gears on the two outboard drive pins. Internal ring gears housing roller bearings are mounted in the ends of the crankcase and receive and dynamically support the crankshaft in the power output shafts. The power output shafts are robustly supported in two low-friction bearings, the inboard end in the ring gear roller bearings, and the outboard end in the pressure-lubricated drive shaft housing journal. The crankshaft is robustly and dynamically supported at the drive pins in the power output shaft drive pin journal, and receives pressure lubrication from oil drillings in the output shaft ported from the drive shaft housing bearing. The output shaft bearing housings. The patent provides for optional incorporation of motor generators. The outputs may incorporate gear, chain, or belt drives for the valve train, pumps, etc. The outboard area of the output shafts may incorporate pressure-fed plain bearings in the drive housing, which feed drillings in the output shaft, lubricating the crankshaft drive pins. The crankshaft may also incorporate drillings from the drive pin, providing pressure lubrication to the crank pin piston journals. Flywheels and pulleys may be incorporated in accordance with the application and provide ancillary drive and balance factor. Geometry-driven straight-line reciprocation and component relationships. Please refer to the Efficient V geometry video on the efficient-v.com website for greater clarity and understanding. The basics. The ring gear pitch diameter equals the stroke. The pinion's pitch diameter equal half ring gear pitch diameter, half the stroke. The crank pin's radial displacement about the axis of the drive pins equals 1/4 the stroke. The cylinder bank angle is described as the V angle. The crank pin angular displacement about the axis of the drive pins is 2 times the angular displacement of the cylinder bank angle, 2V. Component relationships in operation. As the pistons reciprocate, the planetary crankshaft describes 2 orbital paths simultaneously. The crank pins received in the piston elongate journals revolve the crankshaft about the drive pin axis, revolving the pinions, which are engaged with the internal ring gears, which revolves the planetary crankshaft about the central axis of rotation of the output shaft. the crank drive pins are engaged in the output shaft drive pin receiving journal, revolving the output shafts. Balancing factors. The planetary crankshaft may be balanced unto itself with counterweights in accordance with mass requirements, not shown in this model. Output shafts may incorporate drillings and counterweighting as needed for balance of reciprocation and rotation masses, including the motor generators. Flywheels may also incorporate mass balancing as the application indicates. Lubrication and cooling notes. Pressure lubrication may be provided by conventional wet or dry sump arrangements. Narrowed cylinder elongate piston journals may be drilled for oil porting to a corresponding elongate piston journal which have oilway grooves that in reciprocation provide high pressure pumping action, delivering oil to the crank pin through drillings from the oilways to pin journals. Piston head may also receive cooling oil through drillings in the piston stem. Engine cooling may be conventional liquid or air cooling. Other considerations and benefits. Straight line reciprocation dynamics are geometry driven, and unlike crank rod slider mechanisms, are not dependent on high friction guidance by the containing cylinder and enables reduced piston ring tension. In applications optimized for maximum fuel efficiency, for example near steady state or hybrid power applications, piston elongate journaling between the piston and cylinder may be eliminated for minimal friction. High efficiency V4 applications may optionally eliminate piston elongate journaling in outboard cylinders to minimize friction losses. In high output, maximum cylinder pressure, highly turbocharged or supercharged gas and diesel applications, piston to cylinder elongate journaling promises unrivaled robustness and durability, and when combined with displacement reduction, outstanding power and fuel efficiency. Original equipment production valve train, fuel, ignition, cylinder head, hybrid, and emissions technologies are highly developed today, and if combined with the core Efficient V piston engine technology, promises great improvement in overall efficiency. Summary. We encourage you to further explore Efficient V at efficient-v.com and share with your friends. We are seeking strategic partners to join us in advancing this exciting new technology. Thank you very kindly for your time and interest.